Welcome to this short presentation on probability. This is a sheet that I sent to you last week, and what we're going to do today is just go through these points starting at A and working through to J. I'm going to sit down to show you these, so hopefully you can keep with me. The first one, what this sheet is actually asking you to do is say one of three things, whether something is true, false, or if you don't know, or unsure, or there's not enough information to say whether it's correct or not. So looking at the first one, the question or the statement says, when you roll a fair-sided six-sided die, it is harder to roll a 6 than a 4. So we look at the probabilities for a dice. There are 6 sides, and 3 of the numbers are even, 3 of the numbers are odd. And if we look at these two numbers, 6 and 4 are both even. They both have a probability of 1 out of 6, so that is false. Looking at the next statement, scoring a total of 3 with 2 dice is twice as likely as scoring a total of 2. Again, if we look at the probabilities, we have, if we look at, we need to draw really a table as probability space. So this would look something like this, where you consider this being the first dice, this being the second. And if you add the probabilities together, if both dice fall on a 1 and a 1, we get a total of 2. If the first dice falls on a 2 and the other one on a 1, we get a score of 3. We get a 3 there as well. I don't really need to go any more than that, because a total of 3 with 2 dice is twice as likely as scoring 1 with 2. There's only 1 with 2, and there's 2 3s. So this one is true. In a lottery, 6 numbers, and these numbers are more likely to come up with than these 6 numbers. This is false. Probability of lottery draws is the numbers have no memory or anything like that. So this set of numbers is just as likely as this set of numbers. Apparently this is a very popular sequence. I think it's something like 10,000 or more people every week use this first set of consecutive numbers. So, you know, even if you did choose that set of numbers and came up, you're likely to be sharing it with quite a lot of other people. But anyway, the answer is false. Going on to the second one, this one then, D. When 2 coins are tossed, there are 3 possible outcomes: 2 heads, 1 head, or no heads. The probability of 2 heads is therefore 1/3. The probability of each of these is a half. So again, this one is false, not 1/3. Okay. There are 3 outcomes in a football match: win, lose, or draw. The probability of winning is therefore 1/3. This is really dependent on lots of issues. Reality is, looking at these 3, you would agree with this 1/3. However, it depends on the teams playing. If you've got a Premier League playing an unregistered team, then that wouldn't hold true as being the correct probability. So you could say this is false or uncertain, depending on the conditions. In a true or false quiz, 10 questions, you are certain to get 5 right if you just guess. Well, again, this is false, for the simple reason that the word certain, in probability terms, certainty is equal to 1. And that means that you're exactly going to get 5 right if you just guess, or we can't be definite for that. So the word certain means that it's false for this particular statement. If you toss a fair coin 5 times and get 5 heads in a row, the next time you toss a coin is more likely to show a tail than a head. This is a little bit like this question. So this is false, in the same way that a coin doesn't have any memory. It doesn't know whether it's landed on heads or tails, just like lottery balls don't know what numbers come out before them or what's coming out afterwards. So again, this one is clearly false. Now here's a question that catches quite a few people out. In a group of 10 learners, the probability of 2 learners being born on the same day of the week is 1. 1 is certainty, so this is true. and it's true because if we think about the number of days in a week, we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. There are only 7 days in a week. So there are 10 learners and there's only 7 days in a week. So by consequence, we have more learners than numbers of days in the week. So this statement must be true. Okay, moving on to statement I. If a family has already got 4 boys and the next baby is more likely to be a girl than a boy, this again is false. Simple reason. In the same way, I suppose we could categorise lottery balls and coins. There's no pattern to how many boys or girls you get. The probability mathematically is half for a boy, half for a girl. So there's no likelihood that because you've had a succession of one particular sex of baby, that the following one is going to be the same or different. Okay, the last one then, probability of getting exactly 3 heads in 6 twin crosses is a half. This again is false. If we look at the Pascal's triangle to answer this question, Pascal's triangle starts like this. On row 1, we have 1 and 1. Then we have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And the 6th row is going to look like this. 1, 6, and we have a 6 and a 1 on this side, 15, 20, and 15. So this row here, the probability, if we add all these together, is 64. So heads, 6 heads in a row is 1 out of 64. And 6 tails is 1 out of 64. So these are the combinations here of, so this one in the middle here is the even number of heads and tails, and this works out at 20 over 64, which is not equivalent to a half. So that one required a bit more thought. So again, that one is false. Okay, well thank you for listening for those. Hopefully that gives you a bit more of an insight as to these particular statements and some of the problems associated with probability. In the next session, we'll look at some similar examples because obviously probability is often classed as counterintuitive. Thank you.